Welcome to the last reason that we need to know for the triangles. And once we're done with this reason, and this is one of the common reasons, so one of the three common reasons, and the other two we just went over. This is the third reason, and it states angles opposite equal sides, or angles op equal sides. I'll get into the full description of that when we actually do the examples. Okay, so when do we use this? When do we use this reason? We only would use this reason if we have a triangle that has two equal sides. And what is a triangle that has two equal sides? We know that that is an isosceles. So isosceles. But don't say isosceles, just say isosceles, because that's how it's pronounced. Now, what do we know about an isosceles triangle? And I think, let me just be more fancy there. We've got a triangle. What is the properties of an isosceles triangle? If you remember from the introduction video that I made, isosceles triangle with these symbols over here, only two sides are equal to each other. And those two sides must actually be next to each other, which they meet up at some point basically. Those are the two sides that must be equal. And now, well, those are the two sides that can only be equal in this case. But what else do we know about an isosceles triangle? We know not just two sides are going to be equal in length, but two angles will be equal in length. So if I say, and if you can remember where the angles were, it was here. So if I say that this angle is angle X, then this angle here also needs to be angle X. Okay, before we get into the example or how to actually find out angles using this reason or how to apply this reason in examination questions, we first need to look at this definition here. Angles opposite equal sides. What is it in full? Let me actually just say it out loud. So the angles that are opposite each other are only equal when the adjacent sides are equal in length. Now, what does that mean? I'm actually going to try and represent it visually. So the angles, which are angle X over here, these angles, these opposite angles here, are only equal if these two adjacent sides are equal in length. Basically that. And this is just the reason in full. This is just as simple as I can get right now. And remember, adjacent means besides, next to, close together, or just right besides one point or one side, anything. Yes. Okay, let's do an example here. It's not that much work, but let's just do the example. We have this angle. Let's say, for example, this angle here is going to be 35 degrees. And because this angle is 35 degrees, we can actually say that this x is this also 35 degrees. But let's just take it one step at a time. I'm going to add in an angle over here. We want to find out what y is as well. So if we were given a question where you just have a triangle, and let me get rid of this this red over here. If we look at this triangle, we have two variables. You probably at first, if you didn't know that this rule or this reason existed, you probably think, how on earth am I going to get this now? But because of the information we have, these symbols indicate that these two lines are exactly the same in length, and therefore we can say that this angle over here, adjacent to these sides over here, or these opposite angles over here, are going to be equal to each other. Now let's write that down over here. Okay, so we have x is equal to, what did we say it was equal to? 35 degrees. We're going to cut the naming some slack over here. I know I could say triangle ABC, but I'm not going to do that right now. And obviously, for our reason, we have to add the reason. It's going to be angles op equal sides. Alright, now that we know what our x value is, let's just replace it on the diagram here. Our x value is going to be equal to 35 degrees And how are we going to find angle y over here? Well, we can clearly see we know two angles of this triangle. And to find that angle y, which is the unknown variable of the triangle, we just need to add all of these angles together to give us 180 degrees. And which reason is that? That is the sum of angles in a triangle. So we're going to look at it like this. We're going to say y is equal to 180 degrees minus, and we said 35 degrees plus 35 degrees minus 35 degrees. But you can also write it like this. If you want to be fancy, you can actually write it as 2 times 35 degrees. If you want to be fancy. What obviously this just means is that 35 degrees is multiplying to, is going to be multiplied by 2. So it also can be written as 35 plus 35. And then the negative obviously will just go into this. Let me actually just see if I can explain it a little bit better. That 2 times 35 just means, and please note that we also have a negative here. It's going to be 35 degrees plus 35 degrees, because it's basically just adding the thing twice. That's what the 2 times means. And then obviously, because we need to consider this negative sign over here, it's going to go into this sign over here. Remember, this was positive as well. It's going to affect this positive sign, and it's going to affect that positive sign, and then it's just going to be negative and negative. So it's going to be minus 35 degrees minus 35 degrees, and that is why it's the same. So I think it's best to like practice these things so you can get used to it, and it becomes like just second nature to you. So how do you write that down over here? We have y is equal to 180 degrees minus 2 times 35 degrees. What is 2 times 35 degrees? It is 70 degrees. So if we say 180 degrees minus 70 degrees, it's going to be 110 degrees. Very accurate scale right here, I know. As you can see, this angle here is clearly it's clearly 110 degrees. Okay, but like jokes aside, let's not focus too much on the scale. So therefore, we can actually conclude over here that this angle here is going to be 110 degrees. I really need to consider my scale. I think I should do that. So 110 degrees. And obviously, all of those angles together will give us 180 degrees if you add them all together. This looks more like the Greek alphabet symbol, but let's not focus on that. So that's basically an application of this type of question. When you have two variables, it may look like, oh, okay, you can't really do much. But obviously, when you have just this, if we have this unknown variable, we can use this rule over here, angles opposite equal sides, and then we can just solve for our variables. And also, I know if you were shouting at me through the screen, I forgot about this. It's the sum, and obviously you should know. It's going to be the sum of angles in a triangle. That's our reason over here for this one. So yeah, that is all the reasons for the triangles. This is the third and last one. The next videos will actually cover similarity and congruency, which is probably one of the more not so fan favorite topics, but I will show you how much easier it's actually going to get. It's actually really not that bad. So stay tuned for the next couple of videos on triangle geometry, and then we will end off with quadrilateral geometry.